In the last video, we figured out, how many different ways could, I don't know, five people sit in 3 chairs. So for example, if this is chair 1, this is chair 2, this is chair 3, we said, well, in chair 1 we could put 5 people, no one's sitting down. Then there's only going to be 4 people left, so we could put 4 different people in chair 2. And then there would be 3 people left that we could put in chair 3. So the total permutations, the different ways that people could sit in the different chairs, if we cared about the order, if we cared about which chair they were sitting down in, it would be 5 times 4 times 3. And another way of thinking about that, 5 times 4 times 3, that's the same thing. That equals 5 times 4 times 3 times 2 times 1 over what? Over 2 times 1. Right? And that's the same thing as 5 factorial over 2 factorial. And now where does this 2 come from? How is 2 related to the 5 and 3? Well, it's the difference between the two. So this is the same thing. This is equal to 5 factorial over 5 minus 3 factorial. And that in general is how we figure out how many permutations can how many permutations can 5 things place themselves or be placed into 3 positions. And the general formula is, and we learned this in the last video, and I will switch colors, that if we want to put n things into, I don't know, k positions, and k has to be less than or equal to n. Well, actually, it doesn't have to, but for our purposes right now, assume it is, because our formula might break down if it weren't. And that equals n factorial over n minus k factorial. I always find this harder to memorize than just thinking about the spots and just saying, oh, well, 5 people, 5 of the things could be here, and then once one thing is here, there's 4 possibilities left, and then there's 3 possibilities left. So I just kind of take the first, the way I think of it, I take the first k terms of the n factorial, or in this case, I take the first 3 terms of the 5 factorial. 1, 2, 3, 5 times 4 times 3. That's how I think of permutations. So what if this is great if we cared, if we, let's say these are people A, B, C, D, E. So these are the 5 people that are going to sit in the chairs. This is great if we really cared, if we wanted to count the permutation A, B, C as different from the permutation A, C, B, as different from the permutation, I don't know, B, A, C, as different from the permutation B, C, A. And it will, because remember, when we did this, we actually cared about where they're sitting. And in the previous video, I actually, we double counted everything, because it cares if it matters if person A is in seat 1 and person B is in seat 2, and then if they switch, we recounted, right? This is where they switch. But what if we didn't care about that? What if we didn't care who's in what seat? We just wanted to know how many different ways can the 5 people sit down, right? So we want to count all the situations where person A, B, and C are sitting down as essentially one situation, right? We don't care who's, sitting in which chair. We just care that those are the 3 people sitting down. That's the subset of the people sitting down. And so the question then becomes not how many different permutations or how many different ways can the people sit down. The question becomes how many subsets of 3 can we take out of a set of 5. And that's essentially, and I know I'm kind of jumping up around a little bit, but that's essentially what a combination is. A combination is a permutation where you don't care about the order. So how do we figure it out? Well, when we figured out the permutations using this formula, we counted, for example, we counted ABC, ACB, BAC, BCA, and let's see, there should be 2 more permutations, CAB and CBA. We counted all 6 of these as different permutations. But in our combinations, we're going to want to, this is all essentially the same combination, because we don't care about the order, right? So for any 3 different people that are in these seats, there's actually going to be 6 permutations that we're counting when we do the permutations. So if we want the combinations, we'll just divide by the number of ways we can rearrange 3 people into 3 seats. That's essentially what we did here. So how many different ways can you arrange 3 people into 3 seats? Well, this is kind of another permutation problem, right? The first seat you could put, 3 different people. The second seat you put 2 different people. And the last seat, well, there's only 1 person left. So it equals 3 factorial, which is equal to 6, right? This is equal to 3 factorial, which is equal to 6. Hope I'm not confusing. What I'm just trying to say is, when you did a permutation, we counted all of the different orders of how people could arrange themselves. And what I'm saying now, well, how many different ways can people arrange themselves? Well, it's going to be the number of places factorial, right? Because if we have 3 people in 3 spots, or let's say 4 people in 4 spots, the 4th spot can have 4 people, the 2nd spot can have 3, and so forth. The 3rd spot can have 2, and the last spot will only have 1, right? So it's the number of spots factorial is how many permutations we're counting when we have just the same people, they're just playing musical chairs in the exact same seats. So in order to figure out the combination, so if we wanted to say how many people, let's say if we had 5 people, how many different groups of 3 can be seated? And we don't want to more than double count. I don't know what the word is for counting something 6 times. Well, it's just going to be the same thing as the permutation divided by all of the extra counting we did. We'll just divide by the number of ways that 3 people can arrange themselves in 3 seats. And that's 3 factorial. Right? So in general, I hope I'm making sense. Maybe I'll do a couple more examples in other videos, and definitely request it if you think this is extra confusing. So in general, if we say, what are the different ways that n things can be chosen, or the number of combinations that n things can be chosen into sets of r, where r is less than or equal to n, it's equal to the number of permutations you could create of putting n things into r spots divided by r factorial, right? Because we're going to divide by the number of ways the r spots themselves could be rearranged, because we don't want to count those as extra. And so if we go back to this formula up here, well, this was a k, but now we're saying it's an r. This is the same thing as, so the permutations was n factorial over n minus r factorial. And now we're dividing everything by r factorial. So that equals, so let me just write this. And this is often written as n choose r. Another way it's written is n choose r. This is called the binomial coefficient, and we'll do a whole series of modules on that as well, because this actually shows up in polynomial expansion when you take polynomials to powers. But this is equal to n factorial over r factorial divided by n minus r factorial. You could memorize this. It's useful if you want to do things quickly on tests, but it's very important to think about where it came from. Right? The n factorial over the n minus r factorial, this is just the permutation. And what is that? Well, that was just the first r, I guess you could call it the first r factors, the r largest factors of n factorial. That's all that is. And then when we do the combinations, we divide it by r factorial, because we want to divide it by all the different arrangements that the people could seat themselves in r seats, or the balls could be placed in r cups. So in this situation, if we want to know how many different groups of 3 can be selected from 5 people or from 5 letters, it's going to be 5 factorial over 3 factorial times 5 minus 3 factorial. And that's 5 times 3 times 2 times 1 over 3 factorial is just 6. We'll put that aside for a second. Divided by, this is 2 factorial, 2 times 1. So notice, this is the permutation part right here. This term just gets rid of the 2 lowest factors. You get 5 times 3, 5 times 3, oh, sorry, there's a 4. 5 times 4 times 3, right, which is the number of permutations. And then we divide by 6, because we get 6 permutations for really every combination. Maybe that confused you. But anyway, so we get 5 times 4 times 3 divided by 6. And that's what? 5 times 12 divided by 6, which is equal to 5 times 2, which is equal, there's 10 possible ways that we could take sets of 3 from a group of 5 things. See you in the next video.